Hello everyone, my name is Tanvir Irfan Chaudhary from Marshall University. Today we are going to talk about our TVCC journal paper, A Wheelchair Locomotion Interface in a VR Disability Simulation Reduces Implicit Bias. In our usual study, we used Unity 3D game engine to create a virtual model of A20 Center where the participants navigated using the assigned locomotion interface and listen to the information about multiple sclerosis from the narrators, either with disability or without disability. One of the navigational interface we used in this study was wheelchair. The technical details of how wheelchair works in our study can be found in the paper in details. The second navigational interface we used in this study was in-place walk. To move forward, the participant had to walk in place. Make movements of 2 feet up and down alternatively. To make a turn, the participant had to physically turn to the directions. We used various questionnaires in this study. We have used disability IIT in our user study. We were mostly interested in the difference between two IITs taken by the participants before and after experiencing the virtual reality disability simulation. We had two independent variables, navigation interface, which has two factors, wheelchair, in-place walk, and information narrator, which also has two factors, person with disability, person without disability. This slide is showing the participant is experiencing the virtual environment in two different locomotion interfaces. This slide is showing the participant is receiving information from the narrator. Hypothesis 1, participant experiencing the simulation through an avatar in a wheelchair will show significantly larger change in implicit bias. And hypothesis number 2 is participants who interact with an instructor with a disability will show significantly higher change in implicit bias toward people who use wheelchair. For the study, we recruited 40 students. We used a 2x2 between subjects design with 4 conditions. The conditions name is formed in this way. First, which of the two navigational interface the participant used, and then which of the two narrator they interacted with. For example, WC and WD means participant used a wheelchair and interacted with narrator with disability. These are the 7 steps that our user study contains. Comparing the result of delta IT score for the condition where the participant used the wheelchair and interacted with narrator with disability versus all the other 3 conditions, we see that there is a statistically significant change in bias in condition WC and WD versus IPW and WD, which is participant used the in-place walk and interacted with narrator with disability. Similarly, there is a statistically significant change in bias in the condition wheelchair NWD versus in-place walk narrator without disabilities. However, we did not see any statistically significant change in comparing the conditions WC and WD versus WC and WOD. While comparing the delta IT score for IPW and WD versus IPW and WOD, that means in these two conditions, participant used in-place walk, but they interacted with narrator with disability and narrator without disabilities. We see a statistically significant change in bias. The results from our study shows that when a participant is in a wheelchair and interacts with instructor with a disability, they show lower implicit bias. In other words, they show a stronger preference towards people who use wheelchairs than the participants who are in uh, all the other conditions. From this result, we can accept our hypothesis 1. We can argue that participants felt more empathy towards people who use wheelchairs. The participants experienced a perspective associated with many people with multiple sclerosis. Especially, our VR disability simulation may have provided the participants an opportunity to put themselves in the shoes of a person who uses a wheelchair via several means. For example, by using a wheelchair for navigation, interacting with the instructor with disability, learning information about disability, etc. And this concept is known as perspective taking self. Comparing the two in-place work conditions, the implicit bias was significantly lowered for the participants who interacted with narrator with disability versus the participants who interacted with the narrator with disabilities. That is why we can accept our hypothesis 2. This reinforces our assertion that the virtual avatar's appearance impacts implicit bias in disability simulation, as suggested by the contact hypothesis or contact theory. They suggest that interaction with other group allows people to sense how outer group member feels and view the world. Due to the shortage of time, we could not discuss many of the findings in our paper. We encourage the viewers to read the paper and reach out to us if you have any questions. Thank you very much.